All right, guys. So this is going to be the voiceover because apparently when we recorded the lab, this didn't record. So I'm just going to give you the voice part of this and I'll have to record it again next week. So what we're talking about right here is that catalase is this enzyme. It's a ubiquitous enzyme in that it's found in almost all living things. So almost every living thing has this enzyme in it. Its job is to break down hydrogen peroxide, which is H2O2. Okay, so that's the chemical formula for hydrogen peroxide. And the chemical formula for the reaction, or chemical equation for the reaction, is H2O2 in the presence of catalase becomes H2O and O2, and O. And then the balanced one, where we keep track of what's on each side of the equation, over here it'll be 2H2O2. This 2 goes with both of these. Becomes 2H2O and O2. Okay, that's balanced because you have 2 times 2 is 4 hydrogens on this side. 2 times 2 is 4 hydrogens on this side. And over here, you have 2 times these 2 oxygens, that's 4. And over here we've got 2 oxygens there, and then these 2 oxygens is 4. Move this up a little bit. There we go. This part, we're just talking about the 4 monomers, and it's not the monomers like it was in the macromolecule. It's the monomers that were in the that were like the ones that are just the pieces. So there's 4 different proteins. Now, when you say 4 different, I mean 4 separate proteins, but they're identical in structure. So the quaternary structure of this enzyme is 4. There's 7,000 active sites on the enzyme, and 800,000 hydrogen peroxides are broken down each second by one enzyme. So that's a lot happening. These 3 places are places where we find catalase in the lab, or places where we can use it. So we're going to use yeast in this, and yeast is a single-celled fungus. Potato has a lot of catalase in it, and liver has a lot of catalase in it, and it's found in an organelle called a peroxisome. Peroxisomes are organelles in the cell that have lots of catalase in it. All right, so now I'm just going to demonstrate the reactions of catalase. So this is my yeast. It's the good yeast with the hydrogen peroxide. And I'm going to take a test tube and just put some good yeast in there. The yeast we were using was from 2013. It expired in 2013, so still good, which is pretty awesome. All right, here we go. I'm going to take the good yeast. So it has lots of catalase in it. All I did to activate it was put it in a little warm water that morning. Activated it that way. Put the hydrogen peroxide in there. All right, take some of that and I'll add it to the container, and you see the reaction happening. So those bubbles are happening because of the oxygen that's being released from the reaction, and then the catalase is breaking down the hydrogen peroxide as the oxygen being released. And in this experiment, I'm going to put some boiled yeast in. So I boiled that for a while and put some hydrogen peroxide in. And we'll see what that reaction looks like. So if it was boiled, that means that the enzyme was denatured. Notice there's no reaction. Those bubbles right there, the top here, those are just from adding the hydrogen peroxide. So that shows that temperature can affect, changes in temperature can affect the enzyme. So this is adding now some good yeast, so some of the stuff that's living. And now I'm going to mix it with some vinegar. And Catalase works best at a pH of about 7. So mixing that together with the vinegar, which has acetic acid in it, means that the vinegar is going to denature the enzyme. So this shows that there's an effect on the enzyme when changes in pH also. I just added that's me adding the hydrogen peroxide in there. And notice we don't really get a reaction with that either. So that shows that the vinegar can denature the enzyme and that the enzyme is sensitive to changes in pH. All right. This is adding some of the good yeast, so the living stuff. I'm going to add a little water to it to see if the catalase is specific for a specific substrate. So is it specific for hydrogen peroxide, or will it break down water? And that shows there is no reaction, so it's not breaking down the water. So that shows it's specific for a specific substrate. And there's our original one, the one we started with the good yeast and putting hydrogen peroxide in. Notice that the reaction's basically done. Those bubbles at the top are just left over from the previous reaction, but the reaction's stopping. So we can add some more substrate. If we add more substrate, we should be able to see that the reaction is going to continue to occur because the enzyme's not used up by the reaction. So we added some substrate there. We'll add a little bit more. It's taking me so long to add it. There we go. So that's showing the enzyme was not used up by the reaction. And so that demonstrates that property, that enzymes are not used up by the reaction. They're still available. And in this experiment, we're going to test whether hydrogen gas was being produced or oxygen gas. Because the original equation I gave you, it was oxygen gas. But let's just see if that's true. And I added some good yeast in there. Now I'm going to add a bunch of hydrogen peroxide and put a top on. I have someone helping me hold that closed. And we're going to light a little stick on fire, and if the stick relights, we'll light a stick on fire, we'll blow it out, and if oxygen gas is being produced, that means that the stick is, and the stick relights inside the container, that means oxygen gas being produced. If it was hydrogen gas, it would explode. So there's me lighting the stick. Now I'll move the computer. Oh, that didn't really help at all. Oh, look, the top blew right off. Let's just rewind that to see that happening. Move that. I'm going to move the computer and then watch this top right here. The top's going to blow. Oh, there it goes. It blew off because of all the gas buildup in there. So I'll make the reaction happen again. I'll add more stuff to it. Do it. Now there's the thing being lit. I gotta blow it out, but it's Corona time, so it's hard to. There, now that's just an ember, and if they take the finger off the thing, notice that the stick is relighting. So that's oxygen gas coming out. If it was hydrogen gas, it would explode. Okay, so that's the end of that video.